This is the first CNC lecture of CAM 810S. The topics: definition of the term CNC, the advantages of CNC, CNC applications, and components of a CNC lathe. Let us start with the definition of the term CNC. Computer numerical control, CNC, is one in which the functions and motions of a machine tool are controlled by means of a prepared program containing coded alphanumeric data. CNC can control the motions of the workpiece or tool, the cutting parameters such as cutting speed, depth of cut, and feed, and miscellaneous functions such as turning spindle on and off, turning coolant on and off, and others. Compared to conventional machining, CNC offers quite a number of advantages. The part to the left could be done on conventional machines, but it would take quite a lot of time. The part to the right, however, can hardly be done on conventional machines. Another advantage is high accuracy. Parts are produced with constant accuracy. Short machining time is another advantage. After the CNC program has been produced and the machine has been set up, machining time for a part is very short. Whether we produce one or many parts of the same type, accuracy and surface quality remain always the same. High flexibility is another advantage. Once programmed, recurrent parts can be produced again and again. Production can proceed according to plan because setup and machining time for parts are well defined. Produced parts can be delivered to the customer right on time. This is a very important factor for customer satisfaction. In case of major flexible manufacturing projects, CNC machines are easily integrated into an FMS. And now some common applications of CNC technology in mechanical parts production. Drilling, turning, milling, surface grinding, cylindrical grinding, sheet punching or nibbling, as it is also called. Laser cutting, for metallic parts, water jet cutting for any material, engraving, and last but not least, wire EDM, wire electric discharge machining, which is frequently employed in toolmaking to produce hardened dies, for instance. Let us now look at the design and the main components of a CNC lathe machine. We start at 6 o'clock at the base of the machine, where we see the machine tool frame. This is the machine tool frame. The slant bed is fixed to the machine tool frame. It is the guide for the Z slide. This is the Z slide. And for the tailstock. The bed is slanted or inclined so that the chips can fall into the chip collector, from where they are removed by a chip conveyor. This one. We continue at 9 o'clock and go clockwise. There is the main drive motor, which is normally an AC servo motor. Like the CNC lathe machine in our lab, this machine is equipped with a clamping cylinder for automatic clamping. Then we've got the main spindle and a 3-jaw chuck for clamping the workpiece. All main components of the machine are enclosed by a sheet metal casing. This one. At 12 o'clock, we see the tool turret, to which the X slide, which is fixed to the X slide. Excuse me. Then there is a sliding door, this one, with a window made out of safety glass. Feed motors drive this one, the Z and the X axis. There is a cabinet for electric components. There is a monitor. And there is a control panel for data input and manual machine control. The tailstock, we have already mentioned, is mounted to the slant bed so that we can turn also long cylindrical parts. We look now a bit closer to the RPM control of the main spindle. We start at 9 o'clock and we go clockwise. The main drive is mostly a 3-phase motor. The main spindle is equipped with a brake unit so that the spindle can be stopped immediately. A Takor generator measures the RPM. The actual RPM value is fed into this comparison thing, where it is compared to the RPM reference input or the set value. And the controller calculates a variable, which is then fed back to the motor, so that we have a closed loop control for RPM of the main spindle. Our concept Turn 250 in the lab is equipped with a 3.7 kilowatt motor with an infinitely variable speed range from 50 to 6,300 RPM. A feed drive. In case of a CNC lathe, the feed drive for the Z and the X axis is represented here. Starting at 9 o'clock, we've got the feed motor, then a clutch with overload protection, which transmits power to the spindle. This is the spindle. And the spindle moves, of course, the slide. The spindle has got a very special design. It's called a ball screw spindle. And the nut is a pre-loaded recirculating ball nut. More about these important components of CNC machines we will talk about later on. Feed drives must have a high amount of feed power, a wide speed range from very slow to very fast, a high acceleration rate. The slide must be positioned very rapidly. We need a high repeatability of the targeted position and a high rigidity to maintain targeted positions. This is the end of the first CNC lecture. Please do your exercises. Thank you.